So our learning target is to classify the types of chemical reactions. So this type of chemical reaction that we are going to classify today is a combination reaction. Sometimes, ladies and gentlemen, we refer to it as a synthesis reaction. So if you see on your outline, up at the top it says combination slash synthesis. So as I go on to my success criteria, I need to be able to, number one, balance a chemical equation. So not only are we going to identify and write these combination reactions, we're also going to balance them. I can describe slash identify a synthesis combination reaction. And second success criteria is that I can predict a synthesis slash combination reaction. Now, what does that mean? Well, given a reactants, given a couple of reactants, you can tell me what will be formed in the combination slash synthesis reaction. As I move on, ladies and gentlemen, the very top problem there. Go ahead and copy that into your notes first of all. We are dealing with aluminum reacting with oxygen. So Al plus O2. Now remember, oxygen is one of our diatomics. It's a super 7. We need to make sure that we know our super and 7 and that we have those as diatomics. What you need to do when we're dealing with this type of a reaction, you need to be able to describe whether it is synthesis 1, 2, 3, 4, or 5. Well, what do I mean by that? Well, let's look first of all at synthesis number 1. Synthesis number 1 says that it is 2 elements yielding a binary compound. Now, this, in fact, is the case. 2 elements yielding a binary compound. However, if I look down a little bit further, look at synthesis number 4. It says that I have a metal plus oxygen yielding a metal oxide. So if I am going to classify this reaction, I say that it is an S4. And you will need to be able to classify these. Okay? So this reaction is an S4. A metal plus oxygen yields a metal oxide, and it says to check the activity series. So pull out your activity series. Let's look at that. Okay? There is a line on the activity series. Okay, I'm looking at my activity series here, and right here on my activity series it states, reacts directly with oxygen giving oxides. So as I am looking at my activity series, I'm dealing with aluminum. Is aluminum above that line right there? Well, as I'm looking, where is aluminum? Aluminum's all the way up here. So is aluminum above that line? Yes, it is. Okay? Yes, it is above that line. Therefore, this reaction will occur. If something were below that line, it would be an NR, no reaction. But in this particular case, yes, it is above that line. So I come back and I say, okay, aluminum plus oxygen is going to give me a metal oxide. Well, what's my metal? It's aluminum, okay? So it's going to give me aluminum oxide. Now, I like to write it out like that. I like to write out the name and then do my formula, okay? Why do I like to do that? Well, I look at aluminum oxide right there. I know that aluminum is 3+ on my ion sheet. I know that oxygen, I know that oxygen is a 2- on my ion sheet. So when I am writing the formula for aluminum oxide, it's going to be Al2O3. Now, what's the final thing that I need to do? I need to balance this guy because it is not balanced. And I can see that with my oxygen there, I've got an even-odd problem. I've got an even-odd problem. So I have to make this odd even. So I'm going to take that to 6. Once I take that to 6, I take that to 6, and that gives me 4 aluminums. So I have now balanced and predicted the reaction. I've balanced and predicted the reaction. My second one there, calcium oxide plus water. Well, I know that there are 2 of my synthesis reactions that deal specifically with water. It's synthesis number 2 and synthesis number 3. So I have to decide which one this is. Is this a nonmetal oxide with water? No, because calcium is a metal. So this is an active metal oxide plus water yields a metal hydroxide. And it tells me on my outline that it must be a group 1 or a group 2 metal. So this is a synthesis number 3. Is calcium a group 1 or a group 2 metal? It is a group 2 metal, correct? So does it meet the specifications? It does. So what is going to be produced? A metal hydroxide. What is my metal? Calcium. So calcium hydroxide is what's going to be produced. Now, once again, I write out the name, then I get the formula. What is calcium hydroxide? Well, calcium is a Ca, it's a 2+. Hydroxide's a OH, and it's a 1-. So I'm going to need 2 hydroxides to go with that calcium. So when I write out my formula, I have Ca parentheses OH, close my parentheses, 2. I clean up all my notes from under it, and I look and say, all right, do I have this guy balanced? Is this a balanced equation? 1 calcium, 1 calcium, 2 oxygens, 2 hydrogens. Is this balanced? It is, isn't it? All right, I'm done. I'm done. Now, looking at my third one, I'm also here. Here's another one that is dealing with water. N2O5 plus water. So I look, is this a S2 or an S3? Well, S2 tells me that I have a non-metal oxide and water giving me an oxyacid. So this is a non-metal oxide right there. So as I am looking at this, I know that this is a synthesis number 2, a non-metal oxide and water, and it gives me an oxyacid. Now, what I do with this particular one is it's like I am going to add the two together. So N2O5 plus H2O. So what I would get is it would be H2N2O6. However, that could all be reduced, couldn't it? I could take a 2 out of that, right? So what would that be? If I would take a 2 out of it, it would give me HNO3. Well, does that make sense? Does that make sense? Well, hydrogen is a 1 plus. What is NO3? What is nitrate? Is it a 1 minus on my ion sheet? Absolutely. So does that make sense to have a 1 plus and a 1 minus, this oxyacid? Absolutely. So as I'm coming back and I'm cleaning this up, I am going to write HNO3 because that is my oxyacid, and I'm going to need to balance this. And if I put a 2 right here, that should balance this particular one up. Any questions? Yeah. Because it doesn't make an oxyacid. Okay? It was a different one. Okay? That was an S, what was it? An S3, not an S2. Moving on. My next one here. PB plus CS. As I'm looking at these, I say, okay, is it a combination number 1? 2 elements. Okay? Could be. Is it an S2? No, it is not. Is it an S3? No, it is not, because it doesn't have water. Does it have oxygen? No. So is it an S4? No. Is it an S5? Ammonia and an acid? No. So this has got to be an S1. 2 elements combining together. Now, as I look, I could have a couple things. I could have a metal and a non-metal. That's not the case here, is it? Because I don't have a non-metal. I could have a non-metal and a non-metal, which is not the case. What is the case here is that I have 2 metals, right? Because Pb is lead, it's a metal. Cesium is also a metal. So my outline tells me that if I have 2 metals, that it is an NR. That is no reaction. That reaction will not occur. Now, my final one I have put on here because I'm going to show you a little bit different with this guy, okay? Now, I look and I go through everything. Is it a S1? It could be. Is it a S2? No, it doesn't have water. Is it a S3? No, it doesn't have water. Is it a S4? No, it doesn't have oxygen. Is it a S5? No, it's not ammonia or an acid. So this one also is an S1. Now, which one of the S1? Well, I have lead, which is a metal. I have fluorine, which is a diatomic. It's a super 7. And it is a halogen, which is a nonmetal. So I have a metal and a nonmetal. So this is a salt. Okay? I am making a salt here. So what I need to do is I need to combine the 2. Now, here's the thing. If you look at lead on your periodic table. Lead is multivalent, correct? What charges could lead take? A +2 or a +4. So you can be correct with either one of those. So I could write PbF 2. Okay? Remember that PB is a 2 plus, F is a 1 minus. So I need 2 of them. So I could write PB F2, and that would be a correct statement. But I could also have lead 4. So I could also put PB F4. Now, if I did that, what else do I need to do here? What? I need to balance it, right? I need to balance it because I'm going to need 2 of those F's right there to give me the PB4. So for that particular one, I could have 2 different answers, and both of them are correct. Okay. Any questions here about synthesis reactions? We got thumbs up? We ready to try some? All right.